Let's take a look at the final review for the final exam. And hopefully, you're going to use this review as right beside you while you're taking the exam. Because I've designed it so that problem one lines up with problem one on the exam. So let's take a look at the problems here. I'm going to work through 1 through 11 in this video, and then I'll do a separate video for the next 11 and so forth. That way, the videos aren't too long to upload. Okay, so looking at problem number one, we're looking for the next number in the pattern. So we need to decide what exactly am I doing to each of these numbers to get the next number. Well, I've got some decimals going on, but if you'll notice, there's only one place behind the decimal each time. And if I just look at the numbers, I've got a 5 and 2 5 and 1 2 5. So it looks like I'm multiplying by 5. Now, one way you could check that is you definitely could put that in your calculator. You would type in something like 2.5 divided by 5, zero point 0.5, and you would get 5. That would show you that you're multiplying by 5 each time. So if I take the next number and I type 62.5 times 5 in my calculator, let's see what I actually would get. 62.5 times 5 gives me 312.5 for the next number in this pattern. Okay, let's look at number two then. This is a good review of solving equations. I see some distributing that needs to happen with the 1/2 and the 3. So I'm going to distribute the 1/2 to each term in the parentheses here. That'll give me 1/2 x plus 1/2 times 5, which will give me 5 halves. Now, here's a little tip. You could turn that 1/2 into a 0.5 and then use your calculator to distribute if you want. Then I've got 12 plus, now I'm going to distribute the 3. So 3 times x is 3x minus 3 times 4 is 12. Over here, that leaves me with 1/2 x plus 5 halves equals. Now look over it. You got the 12 and minus 12. Those are going to go away, giving me 3x. Now, I don't know about you, but I don't really like those fractions. So I'm going to get rid of them. And the way I get rid of them is notice how they both have a denominator of 2. So I'm going to multiply each fraction or each term by 2. So 2 times 1/2 becomes 2 over 2. 5 halves times 2 becomes 10 over 2. And 3x times 2 is 6x. Now, 2 over 2 is 1x. 10 over 2 is 5. And that leaves me with 6x over here. Now I can get all of the x's on one side. I'm going to do that by subtracting an x from both sides here. So I'm just going to subtract x. That leaves me with 5 equals 5x. Now let's get rid of that 5 there by dividing by 5 so that x equals 1. I'm a color person, so I like to color code mine and just kind of add some little extra there. All right, let's look at number 3 then. We're doing really good. Hopefully, remember, this is what's going to help you on the exam because you're going to set this review right beside you while you take the exam and look back at the notes that we've done. Okay, now solving a compound inequality, we're going to solve them individually. So I've got 5x minus 7 is greater than or equal to negative 3. So I'm going to add 7 to both sides. The reason I do that is because it's minus 7, and I got to do the opposite. That leaves me with 5x is greater than or equal to, positive 4. And then I'm going to divide by the 5 so that I get x is greater than or equal to 4/5. All right, and then I'm going to subtract 3 from both sides so that 4x is less than or equal to negative 4. Then I'm going to divide by 4 on both sides. So x is less than or equal to -1. And don't forget, this is an and statement. That's going to be important. Because when we have and statements, we are looking for the overlap. Well, you might say, well, what are you talking about overlap? Let me show you on the number line. On the number line, I'm going to graph x is greater than or equal to 4/5. I know because it has the equal to underneath it, I color in the circle and I shade to the right because it's greater than. Then I've got x is less than or equal to -1. Again, I got it colored in because of the equal to, and I'm shading left. Now, look at your graph. There's no overlap. And when I have an and statement, I'm looking for the overlap. So if there's no overlap, that means I have no solution. Now, friends, if there is an overlap, of course, the overlap is going to be your answer. This one did not have an overlap, so I left it as no solution. Watch out for those. That's only with and statements. Okay, let's keep going. We've got number 4 next, and it's got an absolute value equation. So remember, with your absolute value equations, you're going to form 2 equations. The first one's pretty simple. We're just going to take the absolute values off. The second one, we'll take the absolute values off and we'll change the sign of the answer. So notice instead of just 2, I made it -2. All right, let's go ahead and solve these individually. I'm going to subtract 6 from both sides. I do that because I see a +6 there. That leaves me with 2x equals -4. Then I can divide by 2. X is -2. I'm going to do the same process over here. So I'm going to subtract 6 from both sides. That gives me 2x equals -8. Then I'm going to divide by 2 on both sides so that x equals -4. Now remember, with equations, you can always go back and check. And the way I do that is I simply put the answer in for the variable back in the original equation. So you see how I put -2 in for the x? Then we check and see if it's true. 2 times -2 is -4. And yes, that does equal 2. I know that -2 is a solution. Let's check the same thing with -4. So 2 times -4 gives me -8. -8 plus 6 equals -2. And the absolute value of -2 is 2. So again, we're good. We have both solutions, and I've checked them to make sure they do in fact work in my equation. All right, let's take a look then at number 5. Now, number 5 is a good one. We're asking for the domain and the range. I remember that because of the x squared here, it's going to look something like a parabola. Now, hopefully you're using your graphing calculator. I'm going to use the Desmos calculator because I want you to see um, what I do when I graph it. So let me pull that up quickly. Here we are. I'm going to share that with you. So as it switches over, you should be able to see the graphing calculator here. I'm just going to type this in. My y equals x squared plus 3x minus 4. And you'll notice that I let the graphing calculator do all of that hard work here. Now, I want you to focus in. Remember, we're looking for the domain. And this graph looks like it goes all x's, right? So I'll keep that in mind when I write my domain and range. But look at my range. It looks like it's down here at negative. Did you see how when I hovered over the point, Desmos told me what point that was? Looks like that y value is at negative 6.25. So let's use that as our range value. Now I'm just going to draw myself a little sketch of what Desmos did. By the way, all I did was Google the Desmos graphing calculator. And you know what? That calculator is available for free. I would suggest having it open while you are taking your test. That way you can use it at any point that you need it. Okay, so I remember that that bottom point, that y value is at negative 6.25. That's going to be important when we write our range. Now, my domain, remember how that was that nice smooth U shape? It was any x would have worked there. So my domain is all real numbers. Just in case your domain is given as an interval, you might be able to write it like this. You might see it written like that. That just simply says that negative infinity to positive infinity is my domain. The range gets a little bit trickier because remember, we had that low point at negative 6.25. So I know that all of the y values are bigger than negative 6.25. You'll probably see it written like that. Although, if you needed to write it in an interval, you could say negative 6.25 to positive infinity. We use the bracket to show that it is included. It is part of the range. All right. So hopefully you've got your Desmos calculator ready and waiting for you when you are taking your test. Let's look at number 6. This one's asking us to write this equation in slope-intercept form. You may remember slope-intercept form looks like y equals mx plus b. So we're trying to get the y by itself. Now to do that, we've got to move the x over. So I'm going to add 2x to both sides. Remember, you can't add the 12 and the 2x because they're not like terms. So I'm just going to write the 2x first, simply because I see the x term comes first here in the slope-intercept. Then I'm going to divide each term by 3 so that y equals 2/3 x plus, and then 12 divided by 3 will be 4. Now that I've got it in slope-intercept form, let's remember the m here is the slope, and the b here is the y-intercept. So to answer the second question here, slope is 2/3, and the y-intercept is 4. So hopefully that will help you when you're trying to find your slope and y-intercept. All right, let's keep going. We're doing great. We are on problem number 7. And this one asks us to write an equation in point slope form. So let's put in our notes what point slope is. It's y minus y1 equals m parentheses x minus x1. And we want the point slope version of the line that passes through these 2 points. So the first thing we're going to need is a slope. So let's remember the slope formula. Got a lot of formulas going on here, so you'll want to make sure you have them in your notes. I think that's what the benefit really of having this review right beside you while you're taking the test is because you've got all the formulas you need right there. So for the x1 and the y1, let's use this first coordinate point. And for the x2, y2, we'll use the second one. So the y2 is -1, and the y1 is 3, and the x2 is 3, and the x1 is -2. If you're not sure where I got those values, take a minute and pause here and look at where each of the values came from. We're going to go ahead and subtract in the numerator. So I've got -1 minus 3 is -4. And 3 then plus 2 gives me 5. So my slope is -4/5. Now we're going to use our point slope version of the line. Remember, that's y minus y1 equals m parentheses x minus x1. We already know what the slope is, so I can put the 4/5 there. And then I'm leaving some space because I'm going to put in the x1, y1, but I'm going to let you in on a little secret. You can actually use x1, y1, or you can use x2, y2. Either one technically makes it work. So just be ready for either one. I'm going to go ahead and use the x1 and the y1, and I'm going to make that a plus plus. And there's my equation of the line in point slope form. Okay, let's take a look at number 8 then. This is another one you're going to want to use that Desmos graphing calculator. And I'm just going to put a little note to myself. This is a Desmos calculator problem. Now for this one, friends, I'm going to put this table into Desmos, but I'm going to turn it on its side, okay? So I want you to notice I'm going to put the meal cost in the X column, and I'm going to put the tip in the Y column. So let me adjust just a little bit, going back to my Desmos calculator. I'm going to take this guy off, and we're going to add with the plus there a table. So notice I'm just typing in my values for the 475 meal. Use your right arrow to put in the 50-cent tip. Use your cursor then for the next row. You're putting in a 684 cost and a 90-cent meal. I'm sorry, a 90-cent tip. Again, using my cursor, $12.52, and then $1.50. And then finally $20.42 and $3 for the tip. And then finally $8.97 and $1. Now you'll notice over here on the right that Desmos has been graphing these pieces for us. Very nice for them. I like when they do that. It makes it a lot simpler for us. So we will take a look then at how I can find my line of best fit. Let's go ahead and enter. We're going to use the plus again to include an expression. Now, very important that we type it in this way so that we get the linear regression. So we're going to type y underscore 1. Then use your right arrow, and you're going to type the tilde. So you're going to have to do shift. There we go. Oops, so I've got too many of them. Let's try that again. There we go. And then mx underscore 1. And then right arrow again, plus B. Now I'm going to write that on our note sheet, but I want you to see this beautiful information that Desmos is giving us. They're giving us the M for our regression line. They're giving us the B for our regression line. So I'm going to write this equation down. Let me switch back to my problem here. I'm going to write that down. So after we put it in a table in Desmos, we do Y1 tilde mx1 plus b. And then what Desmos told us was that m was 0.157 and b was negative 0.3. So let's put that in our equation. See, it's telling us the format, and we just write in our values. So y equals 0.157x plus negative zero point 0.3. That's our line of best fit. Now, the question then says, if the next diner orders a meal costing $10.50, how much tip should the waiter expect to receive? So we're going to put $10.50 in for X. I got 1.57 times $10.50 plus negative zero point 0.3. Now you can put this in your calculator. You're going to do your 0.157 times your 10.5. We're going to add our negative zero point 0.3, and the waiter should expect to get $1.35. Okay, so notice on this one, you let Desmos do your line of best fit, but I want you to watch out for what you needed to type in. Make sure you have that in your notes, because you're going to need that to tell Desmos what it is you want it to give you, which is the line of best fit. Okay, just a few more left, friends. We're doing great. We're on track. Let's look at number 9. It says to compare this function with the parent function. So we're looking for the parent function to be the absolute value of x. So remember what the absolute value of x looks like. If you need to graph this on Desmos, please do. It is a V shape. Okay. It's asking you, okay, without graphing, although you can put it in your calculator, what are the vertex, the axis of symmetry, and the transformations? Okay. I think the axis of symmetry is the easiest one to get first. So let me do that. I call it the AOS, the axis of symmetry. Super easy. Set what's inside that absolute value equal to 0. And then you can solve it. I'm going to divide by 6 on both sides after I subtracted 3, so that x equals negative 1/2. That's your axis of symmetry. Let me highlight it so that I don't miss it's part of the answer. Okay. Then, if you want your vertex, the cool part of that is you've already found half of it, because the axis of symmetry gives you half of the vertex. The easy part then is you just have to plug it into the equation for x and solve. So 6 times negative 1/2 is negative 3. Negative 3 plus 3 is 0. Absolute value of 0, still 0. So my y value is negative 1. That means my vertex is at negative 1/2, 1. You see how the axis of symmetry was already half of it? So we had half the work done already. So what it's asking is, now that you know this, what changes were made to this graph to get this information? Well, obviously we shifted, right, to the left and up. Okay. And so let's put that information in here. We shift left and up. Mhm. All right. Let's look at number 10. We need the inequality for this graph. Well, let's just focus on the line first, right? I know that I can write an equation of a line as y equals mx plus b, m being the slope, b being the y-intercept. So go on your graph and identify what that y-intercept is. That y-intercept looks to be at 1, 2, 3, 4. Now I need the slope. So let's just choose another point here. From this point, we rise 1, 2, and we run 1. So I've got y equals 2x plus 4. But this is not a line. This is an inequality. How do I know? Because it has shading. So I need a less than or a greater than. So look at your y-intercept. Did you shade above it or below it? We shaded below. Good. That means we're going to put a less than here. Then ask yourself, okay, well, do I put an equal to underneath it because of the um, dashed line there? Well, a dashed line means that we do not put the equal to. So I'm going to leave it just like that. All right, one more to go for this set. We're doing great. We're on track. Let's graph a feasible region for this system. So y is greater than or equal to 0. This is the x-axis. So it's got a line underneath it. So I'm going to put a solid line with my handy dandy straight edge. Do you do that? Do you use gift cards or library cards or things like that for your straight edges? I mean, you can use a ruler. That's totally fine. I just use what I have. So now if y is greater than or 0, that means we're going to shade above the x-axis. So I've got my little map pencil here, and I'm going to shade up here. All right, now let's do y is less than x plus 4. So for this one, I'm going to start at 4. 1, 2, 3, 4. My slope is 1, so I'm going up 1 over 1. Up 1 over 1. Up 1 over 1. You can keep going up 1 over 1 as much as you'd like. I just want to do a few of them so I can use my straight edge to draw my line. Now remember, there's no equal to underneath there, so there is a dashed line I'm putting here. Dash, 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 dash. All right, now, whoops, now I am less than x plus 4, so I'm going to my y-intercept. I'm going to shade below that. I'm going to choose me a nice color here to shade below. Okay, and one more to go. Then I've got y is less than or equal to negative 2/3 x plus 2. So again, start at that y-intercept of 2. 1, 2. I'm going down to right 3. 1, 2, 1, 2, 3. Down 2, 1, 2, 3. Again, you can go as many times as you like. This time we're going to put a solid line because of the equal to underneath there. You can slide your straight edge over. There we go. And now we're shading below that y-intercept again. Okay, so what you're looking for here is where is the overlap? Where's the overlap of all three of these shadings? And it looks like it's right in here inside of this triangle. So I'm taking a fourth color. Have some fun with the colors here. I'm taking a fourth color and I'm coloring it in just a little bit darker because that is my feasible region for the whole entire system. Okay, so stay tuned for the remaining problems. I'll be sure to add those and I'll add a link to the bottom in the comments here for the other problems. Bye for now.